All right, everyone, the problem states a 334 milliliter cylinder contains 5.225 grams of helium at 23 degrees Celsius. How many grams of helium must be released to reduce the pressure to 75 atmospheres? All right, let's write down everything the problem gives us. First, we have a 334 milliliter cylinder. So that is a volume, 334 milliliters. In that cylinder, we have 5.225 grams of helium. So we have a mass of 5.225 grams. And we are also at 23 degrees C. So we have a temperature at 23 degrees Celsius. How many grams of helium must be released to reduce the pressure to 75 atmospheres? So we have another value, 75 atmospheres. That is our pressure, 75 atm. And we want to know how many grams of helium must be released. So grams would be a mass, and we're going to do m sub r just to get the mass released. That is what we are looking for. So this is an ideal gas law problem where we are going to also have to use the molar mass of our gas. So let's first set up our ideal gas law, also called Pivnert, or PV equals nRT. So that is our first equation we're going to use, and we are going to solve for something we don't have right now. We're going to solve for N, or moles. So let's manipulate our equation to solve for N. So to get N by itself, we're going to divide both sides by everything else on the same side as N, which would be RT. So we have to do that to both sides to keep this equal. And we're doing that so that R cancels and T cancels. So now we can rewrite the equation, and then I'm going to flip it so that N is on the left side. N is equal to PV over RT. So let's plug in what we know. We know that N equals pressure, which is 75 atmospheres, times volume. Now we have a volume of 334 milliliters. We're going to need this volume in liters. So let's do a quick unit conversion. We're going to multiply that 334 milliliters by a conversion factor to get us so many liters. And that unit conversion factor we're going to use is going to have milliliters on the bottom and liters on top. And for every 1 liter, that is 1,000 milliliters. So we're essentially going to take 334 and divide by 1,000, and that gets us 0.334 liters. So that's what we're going to use in our equation down here, 0.334 liters. Okay, and then divided by R times T. So for R, we need to go look at our universal gas constants and pick the one that matches our unit of pressure. So up here we have all of our universal gas constants, or at least a couple of them. Now our pressure is in units of atmospheres. So we are going to pick this first universal gas constant, first value of R, where we have atmospheres as our pressure unit. So on bottom of our equation, we have 0.08206, and then the units on that are liter times atmospheres over Kelvin times mole. Okay, and then that times T temperature. Our temperature is 23 degrees C. Now, hopefully you noticed that our universal gas constants all have Kelvin for our temperature. So we need to get our temperature into Kelvin, just like we needed to get our volume into liters. So we're going to do a conversion here, and for temperature, it's pretty easy to go from Celsius to Kelvin. You just add 273. So 23 plus 273 is 296 Kelvin. So 296 K down there. So now we can solve this for N. So let's get our calculator, and we are going to take 75, multiply that by 0.334, and then we are going to divide by, open parentheses, 0.08206 times 296, close parentheses, hit enter, and we get 1.0312. Let's just cut that off at 1.031, and that is moles because we were solving for N. So that is how many moles we need to have a pressure of 75 atmospheres. But the problem is wanting grams of helium that must be released, because we have in our problem 5.225 grams, which is going to give us a higher pressure than 75. So we now have to get the molar mass of helium and turn these 1.031 moles into grams to give us the number of grams we need for that pressure, and then we subtract that from what we have to get how much we must release. Okay, so again, we have 1.031 moles of helium. That's the amount that will give us the pressure of 75 atmospheres. So how many grams of helium is that? So we have to multiply by the molar mass of helium to get grams of helium. So what's the molar mass of helium? Well, if you look on your periodic table, you'll see something that looks like this for element number 2. Helium has a molar mass of 4.00 grams per mole. So that's what we will use in our conversion factor, where moles is on the bottom and grams is on top. 1 mole of helium is equal to 4.00 grams. So we're going to take our 1.031 and multiply that by 4.00. So we can get our calculator again. It was 1.031, and we're going to multiply by 4.00. You could divide by 1, but that won't change our answer. So hit enter, and we get 4.124. So 4.124 grams of helium is how many we need. Well, we currently had 5.225 grams to start. So if we subtract 4.124 grams from that, we get how many we must release. So 5.225 minus 4.124, 5.225 minus 4.124, hit enter, and we get 1.101. So that is how much helium needs to be released, and that is in grams. So let's cut that off to 1.1 grams. Okay, so final answer for a 334 milliliter cylinder containing 5.225 grams of helium at 23 degrees Celsius. How much helium needs to be released to reduce the pressure to 75 atmospheres? That would be 1.1 grams. All right, if you want to see another example, click in the top right. Please like this video if it helped you in any way. Feel free to look in the doobly-doo below for additional help and resources. Please subscribe and ring the bell to get notified for new videos. And thank you so much for watching.